Okay, so we're trying to understand PMOSs. So right here, we can see what our design looks like. So we basically have a NMOS right here, and we're connecting a voltage to the gate, and the source is connected up to a 9-volt supply. And then we have our drain right here with a resistor down here. So if we start off, at this point, you see this one right here is okay, so starting off right here, we have our gate voltage. So right in here, you can see our gate voltage is really low. So then this red one right here is showing how far we are from threshold. So if we have 0 volts in the gate, that means across our gate to source, we have 9 volts, which means that this one has a threshold of 4 volts. So you see that we're 5 volts above threshold. So that means that we're conducting as much current as possible. Now, when we conduct a lot of current, you can kind of see that our drains right here, our drain to source from here to here is going to be really large. And so this one right here is how far, this is our drain to source voltage, which is right here. So what we see here is that our gate to source voltage minus our threshold is way larger than our drain to source voltage. So that means that in this region, we're in triode. Okay, so now as my gate to source voltage is starting to move up, then you can kind of see that my drain to source voltage is moving down. Okay, but my current is staying fairly flat. Okay, because everything depends more on the drain to source voltage. And then eventually you see we get to this point right here. And in this point right here, you can see that my gate to source minus my threshold is about the same as my drain to source voltage. So this is where we are transitioning from triode into active. So in this region right here, we're inactive. So when we're inactive, you see that the current is directly proportional to my gate to source voltage. So as this voltage starts to move down, so as this is moving down, you see that this current is moving down. Okay, so when we're doing that, now that our current is doing that, means that my drain to source is going up. Okay, so then my drain to source keeps going up until I hit this point right here. And this point right here is when we cross 0. So this is my threshold. Which means that once I cross threshold, now I'm in cutoff. And when I'm in cutoff, there's no current. If there's no current, then my drain to source voltage is just going to be the 9 volts.